Welcome to Dayla's class, brought to you by Alondra, Sofia, and Carmen. Imagine you are enjoying a beautiful day in nature, near the beautiful, clean water. Suddenly, you notice an icky black substance dripping off of some rocks nearby. What is it? It's the awful sludge of polluting oil, left over from an accidental oil spill in a nearby bay. Luckily, environmental engineers are working hard to help clean up this terrible mess and return the waters to their healthy, beautiful state. So, how do they do it? Well, this is done through a process called bioremediation. Bioremediation is the process of using living microorganisms, mostly bacteria, to remediate or clean up pollutions, such as man-made chemicals found in oil. Biodegradation is the process of living organisms breaking down matter for energy. So, what is the difference between bioremediation and biodegradation? Engineering, of course. While biodegradation happens naturally, engineers are involved in bioremediation. Engineers create products to help nature do its job of getting rid of pollution. Oftentimes, biodegradation does not take place naturally because the bacteria present do not have one of the essential needs for living things, for example, water, living space, or homeostasis. Engineers come to the rescue by providing these needs. In today's activity, you get to be environmental engineers, cleaning up an oil spill through bioremediation. Luckily, there are organisms that can help eat up the oil and turn it into harmless substances. So how are we going to do this? Well, let's find out. For today's activity, you will need 3 test tubes, 3 balloons, measuring spoons, sugar, yeast, and water. You may also use additional liquids, but these are optionals. In the video, you will see me use soda and white vinegar. We will begin by measuring out our ingredients. I use 1/4 teaspoon for the yeast, and then 1/2 teaspoon for my sugar. Once your ingredients are measured out, you may pour them into your tube. I put my ingredients into this piece of paper so then I could funnel them into my tube. Once my ingredients are in my tube, I will add my liquid. In this case, it will be water. Once my liquid is in, I will grab one of my balloons and put it around my tube. I will explain why in just a second. If you're up to it, you may also use other liquids and follow the same step. Measure your sugar, your yeast, put them into your funnel, and you may add things like vinegar and soda. Think of your tube with water as your control and the one with vinegar and soda as experimental. So what exactly are we looking for? What was the purpose of doing this? Well, the sugar that you are using represents the oil, and the yeast represents the organisms that clean up the oil by eating it. When the yeast eats, it gives out carbon dioxide, much like we do when we breathe out. We can't really measure gas without having to hold it into something, so we are using balloons. The more our balloon expands, the more carbon dioxide that it was given off. And the carbon dioxide was given off whenever the yeast ate. By looking at how big the balloon gets, we are able to tell which conditions are the most ideal for the yeast to grow in. This is the reason why water was used as a control, while white vinegar and soda were used as experimental. So now it's your turn to let me know your findings. Let me know. What liquids did you use? How much do your balloons grow? If you have any questions, let me know in the comment section. Thank you for joining me today.